In today's fast-paced digital landscape, organizations need more than just traditional bots. They need solutions that adapt, learn, and integrate seamlessly with their content and systems. At AI12Z, our copilots are powered by cutting-edge generative AI and advanced reasoning engines. These copilots offer real-time adaptive conversations and deep insights, helping businesses make smarter decisions faster. Our copilots are equipped with powerful agents that connect effortlessly to third-party systems through REST APIs and other out-of-the-box integrations. Whether it's syncing with your CRM, CMS, or backend systems, our copilots streamline your workflows, making complex connections feel seamless. And unlike traditional bot frameworks, which are rigid and limited in contextual understanding, requiring constant manual updates and high-code deployments, our copilots deploy quickly and are built to scale, adapting to your business's unique needs. So first, let's explore how traditional bot frameworks work and the revolutionary enhancements with a copilot system. Let's take a moment to understand the challenges that traditional bot frameworks have faced. In the early days, frameworks like Microsoft Bot Framework, Dialogflow, and Amazon Lex were groundbreaking. They introduced automation and basic conversational AI, but despite their potential, building with them often became a struggle. Why? Because traditional frameworks are built on rigid structures, decision trees, intents, and predefined entities. This makes them difficult to configure and even harder to scale. Developers had to spend countless hours manually updating every aspect of the bot. Conversations were often forced, leading to user frustration. Users found these bots challenging to interact with. They couldn't handle natural, flowing conversations because they relied heavily on rules and patterns, lacking the ability to truly understand context. This rigidity also led to inaccuracy, as the bots couldn't handle unexpected inputs or adapt to the nuances of human language. They often produced incorrect responses or simply failed to respond meaningfully. These shortcomings made traditional bots feel mechanical and impersonal, diminishing their effectiveness. But as we'll see, the landscape has changed. AI-driven copilots have solved these issues, offering flexibility, understanding, and advanced decision-making. In traditional bot frameworks, regardless of the provider, the structure revolves around key concepts, intents, entities, training data, and actions. This method is the foundation of frameworks like Dialogflow, Microsoft Bot Framework, and Amazon Lex. Let's break it down. An intent is the bot's way of understanding the user's goal. For example, if a user asks, "What's the forecast for tomorrow?" the intent here would be to provide weather information. Every intent represents a specific action the bot should take, whether it's retrieving data or performing a task. To achieve this, bots rely on entities, which are specific pieces of information extracted from the user's input. In our example, tomorrow is an entity representing time, and forecast represents the data type. Entities add the critical details needed to fulfill the intent accurately. But how do bots learn to recognize these intents and entities? Through training data, which consists of sample phrases or keywords that users might say. As we see in the diagram, these examples help the bot match what the user says to the closest relevant intent. One major drawback of traditional bot frameworks is their reliance on rigid training data. If a user's input deviates too much from the predefined phrases, the bot often fails to recognize the intent, resulting in a non-intent or an unrecognized request. This forces developers to spend countless hours expanding and refining training data, and constantly debugging the system. The same applies to entities. You need to create enough variations to cover different possibilities, which often introduces conflicts between intents. Once the bot identifies an intent and extracts the necessary entities, it triggers an action. This could be anything from querying an API for weather data to booking a flight or ordering a product. While these frameworks have served as the building blocks of conversational AI, they come with limitations, including a steep learning curve, constant manual updates, and challenges in handling more complex, dynamic conversations. One of the most common use cases for bots is answering questions, but with traditional bot frameworks, this can be incredibly challenging. You have to manually create every question and answer, and then train the bot to recognize all the different ways users might ask those questions. This process is slow and tedious. The content delivery team must collaborate closely with the content team to simplify and format the responses for the bot. Unfortunately, this approach often leaves significant gaps, as it's nearly impossible to predict and create responses for every question users might ask. Typically, traditional bots only cover a small portion of an organization's available content because crafting each answer and matching it with the right intent is such a time-consuming task. This is where a copilot using a retrieval augmented generation (RAG) approach excels. It's exponentially faster. What could take a traditional bot months or even years to accomplish, RAG can achieve in hours. By instantly pulling from content stored in a CMS, OneDrive, Google Drive, or other sources, RAG personalizes responses in real time, without the need to hard-code every answer or create specific intents for each knowledge fact. With RAG, the bot taps into your existing assets, dynamically generating answers based on what the user is truly asking. It leverages the full breadth of your organization's content, removing the need for endless manual curation. With traditional bot frameworks, managing conversation flow requires complex flow designs, as seen here. The challenge is that users don't always follow the expected path, leading to broken or disconnected conversations. In real interactions, people often change their minds or switch topics unexpectedly. Handling every possible use case with predefined flows quickly becomes impractical, causing the bot to get stuck or confused. As humans, we naturally expect the bot to understand when the context has changed and adapt accordingly. Unfortunately, traditional bots struggle with this and often force users to restart the conversation from the beginning. A copilot, on the other hand, acts as a reasoning engine. It always remembers the full history of the conversation, allowing it to navigate these nuances with ease. Instead of rigid flows, a copilot can adapt dynamically, handling shifts in the conversation naturally, just as a human would. One of the most critical components of the AI 12Z Copilot is its agents, which come in two types, out-of-the-box and custom. Each agent has a detailed description, and every parameter is carefully defined. The Copilot's reasoning engine, powered by a large language model, LLM, reads through all available agents and their descriptions, determining when and how to use them appropriately. Unlike traditional bots, which rely on predefined flows to handle interactions, the Copilot's reasoning engine dynamically manages multi-step processes using available agents and a system prompt. This enables the AI to seamlessly adapt to real-world conversations without the need for rigid flow designs. For example, imagine a hotel guest asking for a late checkout. The Copilot's reasoning engine doesn't follow a preset flow, but instead creates a plan based on the request and the available agents. Its goal, as set by the system prompt, is to assist the guest in the most effective way. To achieve this, the engine first needs to identify the guest and their room number. It calls an agent that generates a form requesting the guest's name and room number. Once that information is collected, the engine then calls another agent to check if the room is available for a late checkout. After verifying the availability, the reasoning engine informs the guest whether they can extend their stay, providing them with the necessary details. A confirmation email is sent by the reasoning engine to the guest with the information about the checkout time. The entire process is dynamically handled, with each step guided by the system prompt and supported by available agents, allowing the copilot to respond seamlessly and efficiently. In a copilot, the system prompt guides the overall behavior, tone, and response boundaries of the AI. It ensures the AI understands its role within the specific use case and maintains context throughout the interaction. By defining behavior, guiding context, and setting boundaries, the system prompt allows the copilot to generate relevant, coherent, and contextually appropriate responses, without the need for manual flow management. This enables the AI to handle complex, multi-step interactions, all while adapting in real time based on the available agents and system prompt. When a guest asks, "What is your spa like?" the reasoning engine recognizes that this is a question well suited for the retrieval augmented generation (RAG) system. The engine understands that it can pull relevant information from existing content, such as spa descriptions from a CMS or knowledge base, to craft a personalized response. In addition to providing detailed text, the reasoning engine also identifies if visual content can enhance the response. In this case, the image AI matches an appropriate image of the spa to accompany the answer, creating a richer, more engaging experience for the user. By seamlessly combining RAG and image AI, the copilot delivers an informative, visually appealing response, enhancing the guest's overall interaction and satisfaction. As you can see from this diagram, at the heart of the copilot is the powerful reasoning engine. One of its key agents is RAG, which connects to your existing content sources, eliminating the need to create new content specifically for your copilot. In addition to RAG, you can integrate agents that work with structured content, such as a PIM from an e-commerce system, or use a GraphQL agent to filter and refine responses from these data sources. This flexibility allows the copilot to handle complex, multi-step processes, all while leveraging your existing systems and assets. By intelligently orchestrating interactions through these agents, the copilot delivers a personalized, efficient, and contextually aware experience every time. And with that, we've reached the end of this video. Thank you for watching, and we look forward to seeing how Copilot can transform your user interactions.